Hello, in this video, we'll be analyzing the performance of an e-steering system. Analyzing the data from the steering input device, spool, and wheel angle sensor can give us a good understanding of the e-steering performance of the machine. The response time between the steering input device, spool, and WAS should be below a certain tolerance. This tolerance is subjective and differs based on machines. It could also be compared with a baseline tolerance. This can be visualized by plotting the steering input signal, spool, and WAS together against time. This plot is a good indicator if the steering system is behaving correctly. A good test is done by oscillating the steering input command so that the plot will resemble a sine wave. This plot shows the delay and distance between curves and in the target set point at the peaks. To record the data for this plot, a CAN trace will need to be taken. One way this can be done is using CAN King or the CAN monitor built into Service Tool. In Service Tool, make sure all the necessary messages are turned on at the highest transmission rate. For example, 10 milliseconds for the best resolution. Status messages 1, 5, or steering feedback should be used. Using CAN King, the default template can be used, and logged to file should be selected. In the Select Formatters window, double-click on the standard text format and choose hexadecimal. Under the Bus Parameters tab, select the correct CAN channel and check No Initial Access and select Apply. In the Log to Text File window, browse to select the location in which to save the file, then press Start. Go to the Bus Statistics tab and use the Go On Bus and Go Off Bus to start and stop the log. When collecting data, large and small steering movements should be used during sine wave or oscillation testing, as some issues will only be present at high or low flow. Once the CAN trace is completed, the data will need to be copied from the text file into an Excel file. The data can be converted into columns by selecting the Data tab and then selecting Text to Columns. Once the data is separated into columns, filter the CAN identifier part of the message to find the applicable messages relating to the steering input, spool, and WAS. Once the messages for the input device, in this case a joystick, status message 1, and steering feedback are identified, use the communication protocol to decode the joystick position, spool position, and estimated wheel angle. Once these values are decoded, they can be plotted against time to show the delay between each. For more information on decoding CAN messages, please refer to the CAN and +1 function blocks input messages video. Here's an example of good e-steering performance as the spool and wheel angle position are closely following the joystick position, with the distance in phase and set point being minimal. However, this is an example of poor e-steering performance, as the spool and wheel angle take a long time to adjust to the joystick position. Some possible causes of large amounts of delay between the joystick, spool, and WAS are poor gain tuning, bad calibrations, or too slow transmission rates. Refer to the advanced troubleshooting video for more information. That is all for this video. Thank you for watching.